Your strongest password, the one with letters, numbers, and symbols, just got cracked. And now that attacker has full access to your email, your social media, and your bank account. Welcome back to Tech Sky. Today I'll show you exactly how Hashcat cracks passwords this fast, and how to build one that holds up against the same attack. Quick note: everything I show today is for security research and defensive auditing. Test only systems you own or have written permission to access. By the end of this video, you'll know exactly how attackers crack passwords, which password types resist cracking the longest, and how to test your own passwords against the same techniques. Let's get started. First thing we always do is update the system. Run sudo apt update to refresh our package lists, then sudo apt upgrade to install any available updates. Our system is fresh and ready. Let's talk about our tool, Hashcat. It usually comes pre-installed in Kali Linux. Check what version you have with Hashcat version, and you can see the version displayed right here. Now, to crack passwords, we need something called word lists. These are basically huge files containing passwords that people commonly use, or passwords that have been collected from major data breaches over the years. The good news is, Kali Linux already ships with some incredible word lists built right in. Let's see where they live. Type ls-lh/usr/share/wordlists/. Look at all these word lists here. But notice one file really stands out, that bigger one with the .gz extension? That's rockyou.txt, and we need this one because it's the largest among all the others, meaning we have the most variety here. But it's compressed right now, so let's unzip it first. Run sudo gunzip with the path to rockyou.txt.gz and press enter. After extraction completes, you can see it's now uncompressed, and notice how its size also increased more than double. Now here's an interesting question. How many passwords are actually in this file? Each line is one password, so let's count them. Run wc-l with the rockyou word list path. Look at that number. More than 14 million passwords. That's massive. Just to give you an idea of what's inside, let's peek at the first 10 lines. Type head-10, followed by that same file path, and here you can see some basic common passwords right at the start. This file ranges from simple combinations all the way to complex ones if you explore through it. Alright, enough exploring. Let's actually prepare for password cracking now. I'll create a dedicated directory where we'll practice all of this. Run make-dir hashcat-demo and move into that directory. Now here's the thing. To practice password cracking, we need password hashes. In real hacking scenarios, attackers would get these hashes from data breaches or by compromising systems. But we'll generate them manually ourselves so we can really understand how this works at a fundamental level. Let's create our first hash. Write echo-n, followed by I love you in double quotes, pipe MD5 sum, pipe cut -C1 to 32, greater than demo1.txt. This command creates the MD5 hash for the password I love you and saves it to demo1.txt. Press enter. To see what it looks like, run cat demo1.txt, and here it is. Look at that mysterious string of characters. No indication whatsoever that this was the beautiful phrase I love you before it got hashed. Now comes the exciting part. Let's actually crack it. Write hashcat-m0-a0 demo1.txt with our rockyou word list --force. Let me explain what's happening here. The -m0 tells Hashcat we're working with MD5 hashes. The -a0 means we're doing a straight dictionary attack, just comparing the hash against our word list. Then we give it our hash file and the rockyou word list. Now execute it. Watch what happens. Within seconds, boom, cracked. You can see I love you right there recovered along with its hash. See how easy that was? Now here's something useful. After you crack a password, if you want to see it again later, you don't need to run the entire cracking process again. So where can we find our already cracked passwords? If you run catdemo1.txt, you'll only see the hash, no password there. But if you run hashcat-m0demo1.txt-show, there you go. The cracked password appears instantly, without having to crack it again. But here's where things get interesting. What if the password is a little bit tricky? What if it's not exactly available in our word list in that exact form, but other variations of that password do exist? Then what happens? Let's test this practically. I'll create another hash. Run the same echo command with password 3l3ctric in demo2.txt. Notice what I did here? I'm using a password that's clearly based on the word electric, but it's in a mutated form where E is replaced with 3. What do you think will happen? Will Hashcat crack it with the same method? Let's try. Run the same command, but just swap demo1.txt for demo2.txt. And here you can see the result. Hashcat exhausted. It couldn't crack it. Why? Because with this basic method, Hashcat only finds passwords that are exactly in the word list character for character. But wait, what about passwords that use leetspeak? You know, where people replace letters with similar looking numbers or symbols, like E becomes 3, A becomes 4, O becomes 0, and so on. People do this all the time thinking it makes their password stronger. Well, here's the solution. Hashcat has something called rules. Rules are basically instructions that tell Hashcat to try different mutations and variations of each password in the word list. It's not just checking the base word anymore. It automatically generates variations like replacing letters with numbers, adding characters, changing case, and hundreds of other mutations. Hashcat actually comes with built-in rule files. Let's see them. Run ls-lh/usr/share/hashcat/rules/ and look at all these files here. You can see many rule files ranging from small to large, and each one serves a different purpose. These files are basically categorized collections of different mutation rules. Some are simple, some are mixed, some are very aggressive. For now, let's use this one here called best66.rule. It's a good starting point. Run the same hashcat command we used before, but this time add -rpath to best66.rule right before --force. And here it is. It cracked the password that previously exhausted Hashcat completely. Now you're starting to understand the real deal here. It's not just about running commands. It's about understanding when and why to use different approaches. Alright, let's push this even further. Let's try something more crazy and complex using a completely different hash type. I'm talking about NTLM hashes, which are what Windows Active Directory systems actually use. Create this hash by running echo-n 5p1d3rm4n ! In single quotes, pipe, icon v, -t, utf-16le, pipe, openSSL, dgst, -md4, -r, pipe, cut-c1 to 32, greater than demo3.txt. This creates the NTLM hash for this crazy-looking password. Can you guess what the original password is? It's a heavily mutated version of Spider-Man. Let's see if we can crack it. First, try without any rules, just the word list. Write hashcat, but change -m0 to -m1000, because NTLM uses a different hash mode, and use demo3.txt with our rockyou word list. Press enter, and exhausted. Didn't work. Okay, let's try again with the best66 rule we used before. Still exhausted. So what's the problem here? Is Hashcat broken? Is the rule file broken? No. The problem is, we're using the wrong rule file for this type of mutation. This password has really intense leetspeak mutations, so we need a rule file that understands these aggressive transformations. Now you'll really understand why choosing the right rule file matters. Open the rules directory again. See the biggest file there? That's div.rule. But here's the thing. It's not always about picking the biggest file. It's about picking the most efficient one for your situation. Look at this file here, incisive-leetspeak.rule. This one specifically covers intense mutation patterns and aggressive leetspeak combinations. A real attacker who doesn't know what form the password takes would start small for speed, move to efficient rule sets like this, and only use the massive rule files as a last resort. Now run the same command, but use -r with the incisive leetspeak rule instead. And there it is. Cracked. See the difference? You didn't just learn how to run Hashcat commands. You learned the actual reasoning behind choosing the right approach and the right tools at the right time. Now let's push this lesson even harder. What if the password you're trying to crack isn't available in any of your word lists? Not even close. Not even any mutation of it exists in there. Then what do? Let's try this practically. Using the echo command, create a hash for password dxrcti in demo4.txt. First, try cracking it with just the word list, no rules. Change back to -m0 and use demo4.txt with the rockyou file. And here it is, exhausted. Couldn't find it. Try again with the best 66 rule added. Still exhausted. Now try it with the incisive leetspeak rule and watch what happens. It's running, but something seems off. It appears stuck. Press S to check the status, and look at this. The estimated time is 2 hours and 22 minutes. And even after all that time, there's still no guarantee it will actually crack. Here's the brutal truth. It doesn't matter which rule file you try. Even if you throw the biggest rule file at this. If the base form of the password doesn't exist anywhere in your word list, no amount of mutation rules will help you crack it. So how do we break this simple 6-character password? The answer is brute force. Write hashcat-m0-a3 demo4.txt, then write $l and repeat it 6 times, then --force. Let me explain this different approach. The -a3 switches us to brute force mode instead of dictionary mode. Each $l represents one position that should contain a lowercase letter. We have 6 of them because the password is 6 characters long. Same logic as before. Start with the most likely scenario, just lowercase letters, then gradually expand if needed. Now run it. Boom. Cracked in seconds. So you see, the tool isn't the problem. The word list isn't the problem. It's about understanding which method is efficient for which situation. Now this was still a relatively simple password. All lowercase, just 6 characters. But what if it's something truly not simple? Mixed case, numbers, symbols. Here is the moment of truth. Let's understand the actual limitations of password cracking. Create the hash for password. Hash symbol, capital A, lowercase bi, 8, lowercase ng, 3, in demo5.txt. Just for our own clarification, let's try cracking it with our word list first. Run the basic command with demo5.txt and the rockyou path. And there it is, exhausted. Now we won't even bother with rule files at this point, but real attackers might try every possible option before they give up. Let's go straight to brute force with every possible character type. Write hashcat-m0-a3 demo5.txt, then write $a and repeat it 8 times, then --force. Here's what $a means. It represents all ASCII characters. Lowercase, uppercase, numbers, and symbols. Everything. And we have 8 positions, so it's trying every possible combination of all these character types for an 8-character password. Execute the command. You can't even imagine what this is doing behind the scenes. It seems completely stuck. Press S to check the status and see what's really happening. Look at this estimated time on my machine. 314 days and 22 hours, which means more than a year. And this right here is the reason why this seems impossible. Every single character you add to a password increases the cracking complexity exponentially, not linearly. That's why you should always use truly random, long passwords. Mix uppercase, lowercase, numbers, and symbols. Make it actually random, not predictable patterns. This is what actually protects you. So if Hashcat can do this much damage, how do you actually protect yourself? First, length beats complexity. A 16-character password using random words is mathematically harder to crack than an 8-character password with special characters. Hashcat demonstrated this clearly. Every character you add multiplies the cracking time exponentially. Second, never reuse passwords. Each account needs its own random password. This is impossible to remember manually, which is why you need a password manager. Password managers generate truly random passwords, store them encrypted, and fill them in automatically. Third, enable two-factor authentication on every important account. Even if your password gets cracked through Hashcat or exposed in a data breach, the attacker still needs your second factor to actually get in. And fourth, check if your passwords have been exposed in known breaches. Sites like Have I Been Pwned let you check your email and see if your credentials are sitting in any publicly leaked database. Those 4 steps right there will protect you against 99% of password-based attacks. Now, if you want to take what you learned today even further, I've prepared a complete Hashcat command reference document for Master Tier members. Every command, every flag, every rule file explained with real-world examples. You can find it in the Master Library Discord channel. And password cracking is just one way attackers come after you. Your entire digital identity has 7 distinct layers that attackers exploit, and your network identity is just the first one. Next week, I'm dropping the complete deep dive of Layer 2, Device Identity, in the Be Anonymous series. Click the info icon above to join Master Tier. And if this changed how you think about your passwords, hit subscribe. Every video on this channel breaks down a real attack and shows you exactly how to defend against it. This is Tech Sky. Stay curious, stay ethical, and keep learning.